Hello and welcome. Assume you are a diligent scientist entrusted with the crucial task of determining the diameter of a delicate hair strand. Armed with a conventional ruler, you carefully place the hair on a surface, hoping to obtain an accurate measurement. However, your excitement quickly gives way to disappointment as you realize that the coarse markings on the ruler fall short of providing the precision you need. Recognizing the significance of precision in your scientific pursuits, you set out to find a tool that can deliver the exact measurement you require. And lo and behold, you stumble upon the perfect solution: the micrometer screw gauge. The micrometer screw gauge is a highly accurate instrument used to measure small distances, diameter, and thickness with great precision. It consists of a thimble, a spindle, and a sleeve with markings. To begin any measurement, ensure that the micrometer screw gauge is clean and free from any damage before use. This will help maintain its accuracy and reliability in measurements. The micrometer screw gauge is commonly used to measure the thickness of objects, such as sheets of paper or thin wires. To measure thickness using the micrometer screw gauge, gently place the object between the spindle and the anvil. Slowly rotate the thimble to apply gentle pressure until the object is securely held between the measuring surfaces. Take note of the main scale reading on the sleeve, which represents millimeters. Next, look at the markings on the thimble. Each division on the thimble represents a fraction of a millimeter, typically 0.01 millimeter or 0.001 millimeter, depending on the micrometer's precision. Identify the line on the thimble that aligns perfectly with a line on the sleeve. This indicates the additional decimal places for a more accurate measurement. To obtain the final measurement, add the main scale reading to the thimble scale reading. This will give you the total thickness of the object in millimeters. Remember to take note of the decimal places indicated by the thimble scale for precise results. Take a look at a typical example of measuring the diameter of a bulb using a micrometer screw gauge. The main scale reading, as seen on the sleeve, is 8.50 millimeter, while the circular scale reading is 40, meaning 0.4 millimeter. Note that the circular scale has 50 divisions, and the smallest division on the main scale is 0.5 millimeter. Therefore, each division on the circular scale is 0.01 millimeter, which is 0.5 millimeter divided by 50 divisions. Then, the reading in the figure is 8.50 millimeter plus 0.40 millimeter, which equals 8.90 millimeter. It is crucial to handle the micrometer screw gauge with care and avoid excessive force during measurements. Applying too much pressure can result in inaccurate readings and potentially damage the instruments. Always use gentle and controlled movement when using the micrometer screw gauge. To ensure accuracy of measurements, it is essential to periodically check the zero error of the micrometer screw gauge. Zero error refers to any deviation or offset in the zero reading when the spindle and the anvil are in contact but not measuring an object. This can affect the accuracy of subsequent measurements if it is not accounted for. To check the zero error, close the spindle and the anvil until they are in contact without any object in between. Observe the markings on the sleeve and thimble. Ideally, the zero on the thimble scale should align perfectly with a line on the sleeve. If there is a misalignment, note the direction, positive or negative, and magnitude of the zero error. To account for the zero error, subtract the amount of the zero error from subsequent measurements. When taking measurements with the micrometer screw gauge, it is crucial to minimize any parallax errors. Parallax errors can occur if the line of sight is not perpendicular to the markings on the sleeve and thimble, leading to inaccurate readings. Ensure proper alignment and position yourself directly in front of the micrometer for precise measurement. Another error that is peculiar to rotating instruments is the backlash error. To minimize backlash, turn the thimble slowly and smoothly. To summarize, practice with micrometer screw gauge is essential to developing skill and accuracy. Take multiple measurements and compare the results to ensure consistency. If possible, verify your measurements with other instruments or techniques to enhance the reliability of your data. Thank you.